Heat pump is a device which is exactly opposite of a refrigerator. Now what does a heat pump do? Heat pump, as the name suggests, it is a device that keeps a high temperature space at that high temperature. It is a device that keeps the high temperature space at that high temperature. For example, suppose you have extreme winter condition and say 0 degrees centigrade is the atmospheric temperature. We cannot survive in that. Therefore, we use a heat pump or a heater. So we will install a heat pump and make our room maybe 20 or 22 degrees centigrade so that there is hotness inside the room where the atmosphere will be at a very low temperature. So what does a heat pump do? The room that is now at a high temperature like 20 degrees centigrade, always we have to pump in heat so that that high temperature room remains at that high temperature. So a heat pump, it keeps a high temperature space. It keeps a high temperature space at that high temperature. At that high temperature. That is what a heat pump does. Now, how does a heat pump work? Same block diagram I am using. Source, which is the high temperature reservoir, say T1 is the high temperature. Sink, which is the low temperature reservoir where we use T2 for low temperature, and we are installing a heat pump. Now where our focus has to go? It has to go towards the high temperature space. Why? Because a heat pump keep a high temperature space at that high temperature. For example, if this is 20 degrees centigrade and which is a room of 20 degrees centigrade, we need to continuously pump in heat. That is, the heat pump has to always supply heat energy, say Q1, so that this high temperature will remain high temperature. Now, it cannot just supply heat. That is not possible. It is not possible as per the first law. For that, it has to absorb heat from the atmosphere. It has to absorb heat from somewhere. So the best place is atmosphere. So what does the heat pump do? The heat pump extract heat from a low temperature space and it will be giving it continuously to a high temperature space. Now, as per the closest statement of second law, heat cannot transfer from a low temperature to a high temperature. If you want to take or extract heat from a low temperature space and make it travel to the high temperature area, then we need to give or supply work energy. So I will be giving work input just like the refrigerator. If you see the block diagram, it is exactly same as the refrigerator, but the desired output is completely different. The desired output is that the heat pump always supply Q1 to T1. It always supply heat to the high temperature area. Now, if I find COP of a heat pump, the equation is saying desired output divided by the required input. What is the desired output of a heat pump? To supply Q1 to the high temperature area, that is the desired output. And what is the required input? You need to give a work energy. Therefore, I will write COP is equal to desired output is Q1 and the required input is W. Again, I have W is equal to Q1 minus Q2 for a reversible device. So this can be again written as COP equal to Q1 by Q1 minus Q2. So this is the equation that I can use to find the COP of a heat pump. Again, we know that if you consider a reversible process or reversible device, this can be written as T1 by T1 minus T2, which we'll be proving later by using the thermodynamic temperature scale.